So let's talk about where you would find various databases or attribute tables if you were working with different types of GIS data. So I'll go through Geodatabases, which is of course the state of the art. That's what Esri would recommend that we use. There are Shapefiles, which are legacy but still very popular. There are ArcInfo coverages, which are also legacy, and then there are CAD or computer-assisted drawings. Let's start with the geodatabases. So if we're just looking through my computer and we saw a file there called data and we opened it up, how we would store geodatabases is actually as a database inside of that folder. And so we might have a hydrology geodatabase, and if we double clicked on that geodatabase in something like our catalog, we might see a surface water data set that might consist of streams and lakes and any other number of layers or features that we want to include on a map. Geodatabases are great because they can be administered just like any other database. Someone with expertise in GIS doesn't need to know anything additional to administer geodatabases. So from an IT standpoint, they're extremely useful and extremely helpful. One of the legacy type ways that GIS layers were stored is as shapefiles. And in this example here, if we open up this folder, even if we were just on my computer, what we would see is a list of files associated with streams. So this is just one of the layers, and it might also be lakes.shp, lakes.shx, lakes.dbf, all of those files. But in this case, let's just look at streams. With streams, there's a lot of different layers. This tells where the lines are on the map. This tells what map projection it is. But this one here, the streams.dbf, that's like a little database file just associated with the streams layer that would include the attribute information for that streams layer. Even though these are legacy, they're still very popular, I think mostly because they're easy to share. The only thing you have to remember if you're sharing these is if you're sending the streams layer to someone, you have to send them all of these files, or else the GIS layer won't open properly. So even though they're not the most easy to share because you have to grab all the ones that have the same prefix before the dot, they're still popular because they're much easier to share than a full-blown geodatabase. If we go back even further in the legacy of ArcInfo and ArcGIS and Esri products, we would get to an area where things would be stored like this. We would have a folder called data. Under that we'd have a folder called streams, and we might have other folders called lakes or other things. But then in this folder in this folder data, there would be one folder called info. And this would be where the database was located. The info database would include the attribute table for streams and for lakes and for all of the other ones in this greater data structure. So all the hydro data might share an info folder, and that's where the streams and lakes and everything would keep their data and keep their attribute table. These are extremely hard to share. The way that we used to share them, and once in a while sometimes still do, is we have to export one particular layer, like streams, and it's going to write it out as an ArcInfo export file. And this export file is going to have a .e00 extension. And then knowing this, if the other user gets that, they can import this .e00 file, and it will open up a new layer called streams, and that's able to be used in ArcMap or other products. With CAD might just have one drawing that's called hydro.dwg or hydro.dxf, and this drawing is going to have it could potentially have a lot of different layers in it, such as, once again, lakes and streams. These would be organized potentially by colors or by other ways to organize layers, but you can oftentimes have multiple feature classes in each one of those files. And once you get those in, they can be linked to databases, but there's not always a natural database that follows along with an AutoCAD drawing.